Hello, welcome to Chapter 2. We're doing Example 3. Chapter 9, Section 2, where we're talking about characteristics of functions. We talked about finding the zeros from the graph. We talked about finding the axis of symmetry from the graph. Now we're going to find the axis of symmetry from the function, the expression that represents the function. So just to remind you, standard form, we have to be in standard form for this to work. From 9-1, if you remember, we say f of x, or we can use y, equals a times x squared plus b times x plus c. And the only restriction on the a, the b, the c is that a cannot equal 0. All right? A, B, and C, I just want to remind you of this. A, B, and C are not variables. They are absolutely not variables. They are what we call parameters. When we get to like a real function, like this is just the general form, it just tells us what the form of it is. You're not going to see an A, B, or C. You're going to see a 2, a 4, and a 5. Or maybe the next one will be a 7, a -2, and a 17. All right? So the A, B, and C are just simply a fast way of saying the A is whatever is multiplied by the x squared, the B is whatever is multiplied by the x, and the C is whatever is added and tacked on at the end. And like I said, the only restriction for a quadratic is that you can't let a equal 0, because if you multiply by 0, you get 0, and then it becomes linear. The B and the C, those can be 0, and you'll see that a lot of the stuff you've seen before have B and C equal 0. Okay. There's another famous form of a quadratic function, but we don't talk about it in this section. This is called vertex form. Vertex form, and I'll keep with the f of x, is a times x subtract h squared plus k. Now, there's a little bit of a confusion between what means what. Okay, that's fine. This is not going to come up in this section. I'm just explaining where this comes from. That a is the same as that a, but I have to do a whole bunch of stuff with this in order to make this look like that. In other words, I have to take this and I have to simplify it to get it into standard form. Standard form is the most simplified form, where there's no more multiplying, there's no more simplifying through multiplying, and there's no more parentheses, and all the like terms have been added, so it's simplified. Vertex form is not simplified, but I do have the vertex. It shows me the vertex. This is why it's important, which is going to be whatever that h is and whatever that k is. And we talk a lot about this in Algebra 2. We spend some time going from here to here. So if you want to see me explain that, I will post the link to that video where it comes from Algebra 2 in your class. Okay? I just hate dropping something on your lap and saying, hey, by the way, this is true. So I hate dropping x equals -b over 2a without explaining where it comes from. So I just want you to know it does come from somewhere, and I have an explanation in one of my Algebra 2 videos. For now, all we have to do is just figure out what the b is and what the a is. And the axis of symmetry, sorry, I got the hiccups, is x equals, don't forget you have to have the x equals. I take whatever that b is, and I divide by -2 times whatever the a is. They put the negative in front, that's fine, okay? So all I gotta do is figure out what the b and the a are, and then do a little bit of multiplying in the denominator, and then divide or reduce if I need to. All right? So let's do just a couple of examples. We're gonna find the axis of symmetry of y equals x squared plus 3x plus 4. Okay, so standard form, I'll write it right here, ax squared plus bx plus c. That means that my a is the hidden 1. This is 1 times x squared. And my b is the 3. Now, of course, someone's usually asked, what about the 4? Does that matter? Is that important? It matters. It's really important. It's just not going to do anything with the axis of symmetry. What that 4 does is it's the y-intercept. And if I change that number to a number bigger than 4, then my graph, if I did graph it, is going to move upwards. And if I change it to a number less than 4, it's going to move downwards. But the axis of symmetry stays the same. So the axis of symmetry is independent of whatever that number is right there. Okay, so what is the axis of symmetry? Axis of symmetry is going to be the b divided by -2 times a. So my axis of symmetry is going to be 3 divided by -2 times 1. First I take care of the multiplying. -2 times 1 equals -2. So I got 3 divided by -2. And then you can reduce. I'm okay with leaving it like this as a fraction, okay? Probably what I would write is I'd say -3/2. Sometimes people are going to change it to a decimal. I do not need you to change it to a decimal. Sometimes, if it's a multiple choice question, sometimes it'll be a fraction, sometimes it'll be a decimal. But for me, doing it just by hand all the time, fractions are perfectly okay. But that's all that I got to do. Let's check out this one. So it looks like my a is going to be the 2 times x squared, and I wrote 1, and I said 2. My b is going to be the hidden 1. And of course my c is 3, but like I said, that doesn't really matter. So my axis of symmetry is going to be b over -2 times a, which is 2. And if I simplify this, I get 1 over -4. And like I said, you can stop there. If you want to put the negative in front, by the way, I know that, like if you saw Dr. Berger, he put the negative in front. Since in my Algebra 2 class, we develop this from that, the -2 ends up in the denominator, but it doesn't matter, because if I have a fraction, a positive divided by a negative equals a negative, so I can say x equals -1/4, that's okay. And if I say a negative divided by a positive equals a negative, so that's okay. If we're doing a multiple choice test and I don't see any fractions, I'm going to look for this, -0.25, and see if that decimal shows up. Okay, now we're only going to do 2 of these problems, because in the next section where we're going to find the vertex, we have to do this part first. So we will keep practicing this. It's just that in the next video, we're going to take it to the next level. All right, we'll see you there.